here, right? So Ben is our Robin talking. So what is tracing, right? So basically, tracing is for when you get a call that production is down, right? You SSH into a box somewhere. There's processes going nuts. You have no idea what's going on, right? At best, there's something in the log files, right, that might help you. But I'm sure some of us have all been in the scenario where there's just processes pinned to 100% and you've no idea what's going on, right? So tracing can help in this scenario, right? Basically, tracing will allow you to give you a kind of an X-ray or an MRI of your processes as they're running, right? And from this information, you might get some sort of a hint as to what's gone wrong, right? And typically, like in this use case, you know, production is down, so you're under huge time pressure, right? And you also have to figure out why the process is going like that or whatever, right? So any clues you can get at all are really good, okay? So that's one use case for tracing. There's a couple of others, we'll go through them now, right? But just to note that it is a field of computing in itself, okay? So it's used by sysadmins for fault diagnosis, right? It's used by developers for debugging. It's much akin to logging, right? But it's not quite logging, okay? So logging is kind of more high-level analysis of less frequent events, whereas trace events are really, really low-level, really high frequency, okay? And the tracing stuff also has to be really robust as well. So once you turn on tracing, start to gather all these events, the tracer shouldn't interfere with your running processes, okay? So your process should still continue to go nuts and all that, right? And that's to be completely non-invasive, right? And the cool thing about it is that it can be turned on by demand, right? So very often if you have a scenario where there's some process going nuts, nothing in the log files, production is gone down, things are in flames. Sometimes a reboot will sort out the process, right? Which is not good, right? Sometimes you might put in more console logging into the process and hope that when it happens again, you'll get more logging or turn on more verbose logging, okay? So tracing will allow you to get a snapshot of the process at that moment in time with all the events that are going on around it and stuff, okay? Okay, so what it isn't, right, as I said, it's a completely separate area of computing by itself. It's not a debugger, right, but it can help with debugging. It's not a profiler, but it can help with profiling, okay? And it's not a logger, but it can help with logging, right? So it's kind of a mix of strange things, right? So as I said, it's like an X-ray or an MRI of your running system, okay? And it also means that your user apps and your kernel can be traced together, right? I'll talk about this more in a minute. Okay, so in terms of the history of tracing and stuff, right? dtrace was released in 2005. Okay, has anyone heard of dtrace? Show of hands. Is anyone using it actively in production? No. Okay. So around about 2000 or so, right? Sun were under a lot of pressure. Okay, so they were under pressure from Windows. They were under pressure from other Linux vendors. So they had to come up with something that differentiated them from the competition. Okay, so they made a very top-level call that tracing and debugging was going to be a core feature of Solaris, right? And they spent years developing it, right? At huge cost, huge overhead. Okay, so in modern-day equivalents, it would be like Linus and Greg KH and all the other inner circle guys of Linux basically saying we're going to stop everything and we're going to do tracing for a couple of years. Okay. What they did, and they were first to market, and that was 2005, right? It's 2015 now, and dtrace is still held up as a major selling point of SmartOS and Solaris and stuff, right? So it's really good. However, it's really well marketed, okay? But when you actually dig into things, it's not widely used, right? Even on Solaris and stuff like that, it's kind of more of a niche thing. It's hard to use, and you kind of need to be a specialist in writing D scripts and understanding what's going on in order to make the most of it, right? However, by comparison, right, tracing on Linux is completely, the history is far more sordid, right? So when dtrace was released, a lot of the members of the Linux community kind of had dtrace envy and we should have this and etc. But back at that time, there wasn't a huge amount of interest in the inner circles of Linux in tracing. Okay, there just quite simply wasn't. And you can look back at emails on the Linux forums and stuff like that. From the very top guys going, we don't really need this kind of thing. But it eventually got. There was enough interest in it and there was enough marketing around dtrace that they figured it eventually made its way in. So the first pass at making its way in was this thing called kernel markers, right? And then there was kernel probes and user probes, right? But kernel markers were the first attempt at adding trace points into Linux. There was practically a revolt when they went in first, right? Everybody hated them, right? So they were quickly removed. This trace event macro went in, okay? And this trace event macro now is pretty ubiquitous today, right? Throughout all Linux, this one trace event macro is used for doing trace points everywhere, okay? So Linux itself now, there are lots of trace points in there. It's possible to get probes from all parts of Linux. So it's really good, right? And you don't need a tracing tool per se to actually use it, right? So you can use it directly from the kernel, right? So the kernel has this debugfs file system. It's a RAM-based file system for debugging. To turn on trace points or create a probe, you have to, echo 1 to a certain file, and that will enable it or whatever. So the interface is terrible, right? But the point is that they're all there, okay? And if you run a sudo find /sys kernel debug tracing events, so running that command on my local VM there, there's about 1,100 trace points, right? Which is quite a lot, right? 600 of those are syscalls, and then the rest are a mix of various operating things like NFS and the file system and power and all that kind of thing, right? But the important bits are the 600 syscalls, right? So these are the system calls deep within the kernel, right? Also, the tools around Linux tracing as well are kind of, there's lots of them. It's not very clear which are the good ones to use and which are the bad ones, etc. And they're also kind of jumbled on top of each other. So you have some tools that do a bit of tracing and a bit of performance, and some that are just for debugging, etc. The most common tools are perf and ftrace. So they're both in the Linux tree. Okay, that's very important. We'll talk about that later, right? Then there's other tools like systemtap, strace, ktap, EPBF, which looks really good. There's dtrace for Linux. Okay, so this has been coming for years. Oracle, on Oracle Linux, you can run dtrace, right? But you can't just go and download it and install it yourself, right? And it's never going to be in the kernel tree itself, right? Because the open source licenses are completely different, right? And then finally, there's LTTNG, okay, which I'll talk about in a second. There's this guy called Brendan Gregg, who I'm sure many of you have heard of, right? So he's the most prolific author out there about all of this stuff, right? So he was involved in writing dtrace. He wrote the dtrace book. So he worked on Solaris for years. Okay, now he works for Netflix, and he's pretty much doing the same thing on top of Linux, right? In Netflix, right? So his website is the one-stop shop for all this stuff, right? Okay, so just a little bit about syscalls, right? So the syscalls in the kernel are kind of where the rubber meets the road in terms of your application, right? So you may not realize it or not, but any application that you write is using syscalls under the hood at some stage, right? And the most popular interface for talking to the kernel is the GNU-C library, right? So no matter what you're doing, it's probably using GNU-C at somewhere under the hood, okay? And it's a big part of the Linux API. So this is the external API for Linux, right? So it's been stable for decades. New calls are introduced very rarely. And that's in complete contrast to the internal kernel APIs within Linux, which change all the time, right? So, but externally, it's very solid. And that allows Linux to be easily ported to all sorts of platforms and architectures and stuff, So some example of syscalls, right? The most common ones are kind of open file descriptor, connect to a socket, accept, read, select poll on a socket, okay? But for most of the syscalls, there's corresponding trace points. So for open, for example, there's a sys enter open, sys exit open. For connect, there's a sys enter connect, sys exit connect, right? So you can see, even just by looking at the kernel trace points directly, that there's, you can infer a lot as to what's going on there, right? Some links there to just, kernel stuff. LWN.net is great. And there's a book on Linux kernel development if you want to dig into it. It's really good. Okay, so LTTNG, right? So I've been keeping an eye on these tools for years. So the perf and the ftrace and all that sort of stuff, right? The one that kind of escaped me was LTTNG. Okay, and it only came to my attention last year. They did a big release, 2.0 or whatever. They did a new website, and it hit Hacker News. And then I kind of started digging into it and went, God, I should have been using this for, why hadn't I heard of this before? Okay, so they're kind of the reverse marketing compared to dtrace, right? So they haven't done a very good job of marketing it at all, okay? So the guy behind it is this Matthew entrepreneurs or whatever. So he works for a company called Iojs.com. They're based in Montreal. And Matthew is a kernel developer, so he's the guy that was originally behind the kernel markers that went in first, right? And then he's the guy that wrote the trace event stuff that superseded all that, right? So he's been working on this for 10 years, right? And Iojs are kind of a consultancy company that specialises in real-time kernel things, right? So their customers are all in the real-time space. LTTNG, all its new features and everything, product roadmap is driven by their customers, so we're all in the real-time space. So they're coming at this from the kernel up, okay? So there's a link to the website there. So what is it exactly? It's not a single tool, okay? It's a suite of tools that will help you trace Linux kernel and user applications, okay? Incredibly low overhead, right? Because it's coming from the embedded space. 10 years of active development. And it's very easy to use, very easy to install, right? And it started now to be shipped with some of the major distros. I think Fedora, the last release of Fedora, installs it by default. So there's no having to recompile a kernel, which you have to do with some other tracers to get it to work. It's an apt-get or it's a yum install, you know. So it's good. So it's got tracers and viewers. So come to that in a minute. Okay, so the components that make up LTTNG then, right? There's the kernel module itself. So you install the kernel tracer. This is the thing that interacts with the kernel and allows you to access all the kernel events, right? It's got the LTTNG UST, which is the user space tracer. Okay, so if you want to put trace points in your own app, this is how you do it. I'll talk about that in a second again. And then there's various tools, right? So there's command line interface, which is backed up by this LTTNG controller library. There's the registry daemon, consumer daemon for extracting trace data, and relay daemon so you can send trace information over the net and stuff like that, right? So it doesn't all have to be all on the machine. Yeah, I wasn't sure whether to include this or not, right? But this is their big architecture diagram, right? So I'll just run through it really quickly. This is orange. Any of the orange ones are to do with instrumentation itself. The green ones are to do with controlling the instrumentation. The blue ones are related to the trace data itself, and the yellow ones are libraries, right? So over here, we have the kernel, right? So this is trace points from the kernel, and these are the modules this uses. You can get trace points out of Java and Erlang, right? So they're the libraries that they use. And then application traces for C and C++, okay? So all the trace data goes via various mechanisms to the consumer daemon, okay? So for the kernel ones, it goes over shared memory. It's shared memory for C++ applications, slightly different than for the kernel. These are the libraries this is built on, okay? And all the trace information ends up in the storage, and they store things in a binary format called CTF, which is common trace format, right? So they put a lot of time and work into this trace format as well. So it's a binary format and it's self-describing, right? So they get incredible compression on the trace events, okay? So, and all their tools are built to handle gigs and gigs of this CTF data, okay? So they're doing an incredible job on that. Then on the far side then, in terms of how you use it, Babel traces are command line interface, so you run Babel trace over these CTF files and you pull out events and you can graph them and all that sort of stuff. I'll show you that in a second. So they have kind of a suite of Python, so there's Python bindings, right? So they have a suite of kind of Python scripts as well that are kind of pre-canned scripts to do the equivalent of top or whatever it is, you know. And then they have a GUI tool, right, which is based on, it's built on Eclipse, okay, so it's an Eclipse tool. A bit clunky, but it looks pretty good. So that just allows you to open up these CTF files on your local machine and get a nice graphical representation of it. Okay. And if you remember as well, they're coming from an embedded background, right? So if there's a problem on your embedded device, you run your LTTNG stuff, it pulls off this common trace format binary, and then you figure out what's going on from looking at the traces. Okay. Okay, the viewers then, yeah, so the command line viewer is called Babel Trace, the Trace Compass, which is the Eclipse-based thing. The Python bindings, which it talks about, right, so you can write your own Python scripts to open up these CTF files and iterate over them, you know, pull out your own data, whatever way you want. And then the pre-canned Python scripts to do analysis and stuff, right. Okay, so how does this actually work, right? So things are going nuts in production, right? You come along to the box, you do an LTTNG create my session, it creates a new session. You call enable event, right? So in this case we're enabling kernel events, we're going to enable all of them. It obviously accepts wildcards and you can put in specific events and all that sort of stuff as well, right? This add context thing is just to put the PID and any thread vPIDs into the trace as well. They don't do that by default, I'm not sure why, but there must be a good reason. Then you call LTTNG start, right? And then something is happening, right? So there's trace points being collected and all that kind of thing. And then at some point you're going to hit LTTNG stop, which stops the trace points being collected. And then you can call start and stop as often as you want, and it depends to the CTF file. And then finally call LTTNG destroy, right? To destroy your session. So just before I flick over there, right? So as I said, production's on fire. You can tell a lot from the kernel traces alone, right? So if you do a little bit of tracing, get a snapshot for a couple of seconds or a couple of minutes, right? And then have a look at the CTF thing, right? From the kernel calls alone, you can kind of tell what's going on, right? So if it's a disk-related problem, there's going to be lots of IO-related syscalls, or if it's a network-related thing, there's going to be lots of socket activity, So you can get a kind of an indication of what's going on by just the kernel, right? So that's really good. However, it's much more beneficial if you get both the bottom-up and top-down view of tracing, right? So from the top-down then, if you want to put in your own tracing, right, they have this user space tracer, so LTTNG UST. You instrument your app with your own trace points, so you put trace points wherever you want, right? So this can be thought of as logging, except the difference with logging is that it's emitting trace points, right, which are very high frequency as opposed to logging, right? So, and can be turned on dynamically, right? So kind of like logging, but not really, right? And then you link in this lib LTTNG, and that's it. You collect the snapshots in the same way. So start your session, run your app, collect your traces, and then you view and analyze your traces. Okay. So that's kind of the top-down view, right? And that's what the tracepoint macro looks like. So tracepoint event. Hello world is the namespace, so that's what they will appear as in the CTF file. Okay. Then you can have any number of trace points. So this one is just called my trace point. It's arguments and fields, so it's going to take an int in the char. Yep. And then at the end, you call it in your code by just calling trace point hello world, my first trace point, 23 and string or whatever. So you define your trace point macro once, and then you can call this trace point, make this trace point call anywhere in your application. Okay, so we have the bottom-up approach from the kernel, right? And we have the top-down stuff if you put your own trace points in your app, right? The bit in the middle that's missing is instrumenting Node itself, right? So, and that's what we set out to do a few months back, okay? So we've added LTTNG trace points directly into Node, okay? So they landed in Iojs version 1.02 several months ago, or several weeks ago. It's all blur. So it was actually relatively straightforward because of there's code in Node for detracing ETW. ETW is event tracing for Windows, right? So Node already has tracing tracing support for Windows and Solaris. So what was really missing was Linux, right? So we've added in probes around HTTP server request, HTTP server response. So that's really useful, like what requests are coming in, and you can see them as trace points in your tracing. Client request and client response, so that's making calls out. And both of these work as well. So this is the low-level HTTP stuff, right? So it'll work with Express or Happy or whatever, which use the low-level HTTP calls. Net server connection, net stream end, so you can get some information about your streams and general net connections and all that kind of stuff. And then the garbage collection stuff is really useful as well. So when the garbage collection kicks in and when it gets done, right? And obviously, if you see an awful lot of garbage collection events going on in your app, then you know you probably have memory problems, right? So I have a short demo, which I'm not as brave as Glenn, so I recorded my demo, right? So this is just to show how you would use it. So I have a small app. Yes, I'm not brave, right? So yeah. These are some kernel events, right? These are the events coming out of our node process here, right? So we see net server connection, net stream. So that's an LTTNG list, just to see what trace points are going there, right? Over here then we're going to create a tracing session called a demo, and I'm going to save it to this demo file here. Okay, session demo created. Then I'm going to enable all the user space events. Okay, so basically enable all these guys. Right? And then I'm going to enable all the kernel events, which enables several events up there, right? Call start, then I'm going to hit my service. So this is just the log standard hello world service, right? Call start, call stop, right? And then I can run Babel trace on my CTF file here. Pipe it out some more. Okay, so you see there's tons of stuff in there. So this is all the events, right? So all the kernel events that are coming in there. You can see there's memory allocation stuff going on there, some scheduler stuff. And then that Babel trace piped out to grepping for our HTTP server. Okay, so you see, that's the problem with this, right? You see the server start and the server end. Yeah. So I'll just run that again. Yeah. So yeah, this is the work we've been doing. So this is running Iojs 1.0, whatever it is now. Creating our session. Okay, so now we're enabling all the user space events, all the kernel events. It's much slower one as well. Starting our session, right? Running our hello world a couple of times. Okay, so that's Babel trace without any grepping or anything, right? So that just shows pretty much all the kernel events. Right? And then if we grep for our HTTP server, okay, so we should get, there's HTTP server request and response, and we did it 3 times. So the 6 trace events, 6 probes for our 3 kernels. Right. So Glenn is going to give a much more impressive demo in a few minutes. Okay, I'm going to go off on a bit of a tangent, right? So Iojs, right? So you may be wondering, considering that Nearform employs about 40 people and we all make a living out of Node somehow, right? So obviously when Iojs was released, we got a bit concerned. But we remain calm, right? And it's actually looking really good now, okay? So basically, in football terms, right, pretty much the entire players and everybody watching picked up the ball, went to a different field, changed the rules a bit, right? So there's the open governance model, which completely changes the rules about how this is run as an open source project. Have attracted way more people to the community, right? By just doing this and reaching out for help in various areas, right? The other big difference is that the roadmap is company or industry driven, right? As opposed to one kind of company driving the direction of it. So the guys went out and they talked to people in industry and they came up with a roadmap, okay? And the roadmap basically is, breaks down as the following. So the roadmap is trying to fulfill what people want, right? And so there's 1, 2, 3, 4, 5, and this is 6, so there's 6 working groups, right? So there's a working group for stability, right? So stability is all about making it stable, obviously, right? But it now Node will follow Semver, right? So minor releases, patch releases, all that kind of thing, right? So the major releases now are going to be when when the V8 API changes, right? And also they're tracking V8 really closely now. So every V8 release is going to be immediately followed up by a Node release, right? And Node, like the Iojs now, is incredibly fast, right? Even compared to Node 12, which has a really old version still has a really old version of V8, right? Io is just blazingly fast, right? So on the stability front, right? The NAN module, right? So the problem with V8 changing its interface, right? It's to do with any native modules out there will be broken, right? So we've seen this between Node 6, Node 8, Node 10. The underlying C++ API changes for V8 all those times, and there's a mass migration of native modules. But there's a module called NAN, which is pretty much just macros around the V8 stuff, right? So if your module uses NAN now, you're going to be completely shielded from changes to V8. And that should kind of really help keep native modules in sync with V8 going forward, right? So that's going to be part of core now. So that's a lot of what the stability working group is doing. The NG stuff is the next generation, right? So this is looking at ECMAScript 6, ECMAScript 6, ECMAScript 7. All those changes coming down and how they're actually going to affect Node, things like promises, or promises right now. All this other stuff that's going on as part of that ECMAScript. Streams, 4th time lucky, that's all I'll say about it. The release group is, just in charge of releases, right? But there's a lot of work involved in that, right? Making sure it tests fast on all the platforms and all that kind of stuff, right? So there's a lot of work to do with releasing. There's a lot of work going on around localization. I haven't followed it very closely, to be perfectly honest, right? But it should make localization in Node far easier, right? But the best working group is the debugging and tracing working group, right? Myself and Glenn are involved in that, right? Since we put the LTTNG stuff into Node itself, right? So since Iojs, since the fork happened, the Node Foundation has been set up, okay? And there's a reconciliation proposal out to all the working groups at the moment. But it's all going to go through. But what's going to happen is the Iojs is going to become Node effectively, right? So it'll be completely reconciled in. The biggest problem with the reconciliation stuff is long-term support for Node 10 and Node 12. Okay, so it's going to be a little trickier on that, like how you get patches, things that were changed in Iojs and backported into 12 and 10 and stuff, right? But in general, right, Node is in a much stronger place thanks to this fork. So it's a very mature fork. It's gone very well, and it's going to have a very positive effect going forward. Yeah.
You seem like they're really that Node version 12 basically going to be the last version of Node.
Yeah.
As we know, then basically Iojs is basically going to be Node
yeah.
in the future.
Yeah.
That's agreed.
Yeah. That's what the proposal is. Yeah.
I heard the proposal, but I wasn't sure if Johnny.
Yeah, no, that's Joint are just another member of the Node Foundation now. Yeah.
Oh, okay.
So the problem is there's nobody left to work on Node. Right?
Yeah,
everybody's working on
right.
Iojs,
Yeah.
right? And the problem the Iojs guys have is nobody's using it because it's not, stable and stuff. So this is.
Are you guys using it in production yet?
Not in production, no. Yeah. So we're going to be using it very soon. Though. Yeah.
Okay.
How far do you think it is from being production ready?
It's hard to tell if nobody's using it.
Yeah.
You need people to use it
Yeah.
and get some momentum behind it and find bugs and stuff. But no, I mean, in general, like, I mean, they've been really great to work with. Like, in terms of pointing people at a well-run open source project now, I'd point them at Iojs. Yeah, it was really good.
So is it going to rename itself now again?
Yeah, no, it'll just be Node again, and there'll be no Iojs. Yeah.
So it's going to be Node version 13 is going to be Iojs.
Well, it's Iojs is at 1.06 or something at the moment. That's what it'll be. Yeah.
Oh, so okay, because it's going to be renamed to Node.
Yeah.
Version 1.
Yeah, exactly. Yeah. So no more forks, no more branding confusion or anything like that. It's just back to being Node. Yeah.
More revolution.
Yeah. That's it.